Hi everyone, my name is Kevin Bai. We are Team 63, and we're here to tell you how we can predict Bitcoin prices from order book data using deep learning models. So what is cryptocurrency? Unless you've been living under the rock for the last decade, you might have heard something called Bitcoin and cryptocurrencies. But what does this mean? A cryptocurrency is a digital virtual currency that is secured by cryptography, which makes it nearly impossible to counterfeit or double spend based on a distributed ledger enforced by a network of computers. A defining feature of cryptocurrencies is that they're generally not issued by any central authority. Bitcoin, being just the first one, is just one of many examples of cryptocurrency, and each of them offer unique values, whether that's quicker transaction times, better privacy, farming capabilities, or simply just a cool name. They've influenced the monetization of art, and companies whose businesses are built around cryptocurrencies have gained traction, fame across the world. So why do we care? To make money, of course, but too often, whether it's because of our risk appetite or simply because we want to hold, we might end up in a vicious cycle that yields small profits and subsequent losses with zero net growth for the investor. But what if that can be changed? What if we can use sophisticated machine learning and deep learning models to predict the price movements of certain cryptocurrencies? Prior work using machine learning techniques in equities and futures markets suggests that they are likely to be effective predictors of cryptocurrency price movements. Thus lies the reason for why we chose this project of how to use publicly available information to inform your Bitcoin bets. Let's say you're an investor with cash looking to make a splash in the crypto market. You can take your money to exchanges like Binance and FTX, where you can place orders for cryptocurrencies like Bitcoin. When placing any other order than a market order, your order will go into this ugly looking chart on the right. Next, Danny will explain more about the intricacies of this diagram.
Now we'll have a closer look into the FTX order book. The order book is composed of two main attributes, the price and volume of cryptocurrency. Also, FX order can be classified from the supply and demand perspective, where the bid side meaning the price and volume that the buyers are willing to offer, and S side being the price and volume that the sellers are willing to offer. And as you can see from the table at the bottom, each transaction in the FTX order book consists of volume and price data of the bid and ask side. Next, please. So what are we predicting exactly? We want to see whether the price of the cryptocurrency will move up, down, or stable in the future. To do so, we look into the mid price, which represents the middle price between the best bid and the ask price. In more detail, if the moving average of the past K days mid price is smaller than the moving average of the next K days, we classify that the mid price is moving in an upward direction, whereas if the average of the past K days is greater than the next K days, you can say that the mid price is moving in a downward direction. Last but not least, if there's no significant difference between the two moving averages, it can be classified as a stable movement. Next.
So now let's talk a little bit about the model architecture. So first, we implemented the baseline from a paper that we were inspired by. It features 3 convolutional layers and a bidirectional LSTM, and then 3 fully connected layers. Our model, for our model, we chose a more simplistic approach. We were using about 1 order of magnitude less data. So we only used 2 convolutional layers and 2 linear layers, and we made sure we added some dropout to help regularize things. Because we took these measures to simplify the model and add significant regularization, we're able to prevent overfitting on the training data. The baseline model, because it was significantly more complex, had a lot of issues with the validation data because it had a significantly different distribution, which is often the case with financial data. As we can see here, looking just at the class proportions, the stable state was significantly less populous in the validation data, and our model was able to handle that, which was something that the baseline model was not able to do so.
In conclusion, we will next look to see if we will implement real-time trading strategies and increase our data size to have more variation and address the issue of volatility. In conjunction, we will also seek to build more efficient code and speed up our prediction engine to be viable for real-time usage. We are Team 63, and we hope you've enjoyed our presentation.